Hi dear students, welcome you all to the brilliant group of institution. Today we are discussing the IUPAC nomenclature of coordination compounds from your grade 12 chemistry. You know what is a coordination compounds and their IUPAC naming is very important. See, what is a coordination compound? We can represent a coordination compound in a sense that we have a square bracket, right? We will represent a square bracket. In this square bracket, we will place, first of all, we have a metal atom. We have a central metal atom and there will be different type of ligands or same type of different type of ligands, right? So coordination compounds means there is a central metal atom. Mostly the central metal atoms are, D block element like nickel, iron, cobalt, like that. So there will be a central metal atom which is surrounded by, metal atom is always positive, right? Some cases zero charge, neutral charge also there. So coordination sphere, this square bracket is said to be coordination sphere. This square bracket is said to be coordination sphere. It's also called coordination entity. Alright, this square bracket is said to be coordination sphere or coordination entity. What are the types of or what are the species present in this coordination sphere? We have a metal atom. Mostly the metal atoms are D block element and we have ligands. Metal atoms are mostly electropositive element. They're having positive charges. Some cases neutral charge is also there. Ligand is either negatively charged species or neutral charged species. Okay, negatively charged or neutral charged species are called ligand, which can connect with or which can make a bond with metal atom. This is called a coordination compound or complex. So there is a square bracket is said to be coordination sphere or coordination entity. Sometime you can observe some species outside of the square bracket or coordination sphere. For example, here Cl2. The species which is present outside of the coordination sphere is called the counter ion. Alright. So you can see this is the square bracket. This is our coordination sphere. What is the metal atom here? Cobalt is the metal atom. What are the ligands present here? Chlorine and amine. NH3 is called amine. So chlorine and amine. And what is the counter ion present here? Chlorine is the counter ion. Right. This is the representation of a coordination sphere. Different types of representations are there. We can discuss in the topic. So in order to name, if you want to name a coordination compound or a coordination complex, we need the help of some data. All of you from here onwards study properly. First of all, what are the charges of ligand? As I told you, ligands are either negatively charged or neutral charged species. Mostly in grade 12, we are dealing with mostly 3 charges of ligands. Okay, in grade 12, even for your NEET JEE competitive examination, mostly they will prefer these 3 type of ligands. What are the 3 type of different charges of ligand? We have -1, -2 and 0. These are the common charges of ligand we are dealing in grade 12. Some ligands are -1 charge, some ligands with -2 and very few ligands are with a neutral charge 0. Dear all, you can see 3 categories we can make it. You don't need to study the individual this ligand, this charge. No need to study that. Take it as a group. Dear all, chlorine. What is the charge of a chlorine? Cl minus, right? Cl minus. Halogens with a -1 charge. Chlorine, bromine, fluorine, iodine. You know that all of the halogens having -1 charge. Cyanide. What is the charge of Cn? Cn -1. Cyanide charge is -1. Isocyanide NC. Cn is called cyanide and NC is called isocyanide. Both of their charge is -1. What is OH is called? OH, hydroxyl group, right? Hydroxyl, OH charge is -1. NO2 is called in this chapter, we will study that it's called nitrito-N. NO2 ligand is called nitrito-N, where ONO is called nitrito-O. What is the difference, dear all? You know, NO2 and ONO, their molecular formula same, right? What is the difference? Here nitrogen making the bond, here oxygen making the bond with the metal atom. Therefore, NO2 is called nitrito N, ONO is called nitrito O. Okay, nitrito O. Then, what is SCN? Dear all, if you observe SCN and NCS, what's the difference? Here sulfur making the bond with metal atom. Here nitrogen make the bonding with the metal atom. SCN, you know, in chemistry, sulfur, what is called? Thio. SCN is called what? Thiocyanato. Thiocyanato ligand. Whereas NCS is called isothiocyanato, dear all. All these ligands are the charge -1. So all of you -1. These all ligands having -1 charge. So which all ligands having -1 charge? It's compulsory to know, very important to know what is the charges of each and every ligand. Once again, all halogen, fluorine, chlorine, bromine, iodine, all their charge is -1. Next one, cyanide, CN charge is -1. OH, hydroxyl group charge is -1. Then SCN, thiocyanate -1. NCS -1. Then we have NO2, ONO. NO2 is called nitrito N, ONO is called nitrito O. All their charges are -1. So all of you -1. Mostly I told you our ligands having total 3 charges, either -1 or -2 or 0. -1 charged species are these ones. So study as a group. Alright. Only 3 ligands you have. With the charge -2. Dear all, you know very well CO3. What is CO3 is called? Carbonate ion, right? CO3 carbonate. You know what is the charge of CO3? 2-. What is the ion SO4 is called? SO4 sulfate. SO4 2-. I think this is a new one. C2O4. C2O4 charge is also 2-. Dear student, carbonate ion, if it come, we will write carbonato. I will tell you why it's carbonato. Actually, CO3 2- is called carbonate ion. Why it's carbonato? Let's discuss later. And SO4 2- is called what? Sulfato. C2O4 2-, dear student, it's also represented by OX. Dear all of you, C2O4 2-, it's called oxalato. It's called what? Oxalato. Okay, oxalato is expressed by OX also. So C2O4 2-, it's also represented by OX, which represent oxalato ligand. Alright, these 3 ligands are with a charge -2. So only 3 ligands you have with a -2 charge. What are they? Carbonato, sulfato and oxalato. Then what is the remaining? So -1 charge group over, -2 charge over. What is remaining the charges? Neutral ligands are there, 0. Which all ligands are neutral? Dear student, NH3. NH3 commonly called ammonia, right? But in coordination compound, it's called amine. NH3 is called amine. H2O is called aqua, not water, okay? If NH3 coming as a ligand, it's called amine. H2O is called aqua, and CO is not carbon monoxide, okay? It's called carbonyl. CO group is called carbonyl. And what about NO? CO is called carbonyl, NO is called nitrosyl. Dear all. En, very important, En is called, I'll just draw you the structure. What is En? That is CH2, single bond CH2, ethylene group is there with one amine group, one more amine group. This is called, we can say what is the IUPAC name of this compound. Here dear all, this is the parent chain, number 1, number 2. First and second carbon having 2 amine group, right? So it's called ethane, okay, ethane 1,2 diamine. That's the name of En ligand. En is a short form of, OX is a short form of oxalate ion, or it is also represented by C2O4 2-, correct. Here, this is the compound ethane 1,2-diamine. That is the short form. Which one? En. En is called ethane 1,2-diamine. These ligands, their charges are neutral. They are neutral charge ligand. Their charge is 0. So, dear all, what are the ligands with us? So, after studying this table, all of you take a screenshot. After studying this table, please go to the next topic. Okay, without studying the ligand, you cannot able to answer the IUPAC nomenclature. So, -1 charged ligands, hope you clear, hope you studied, and -2 charged ligands, only 3, and neutral charged ligands. What are the neutral charged ligand? Amine, aqua, carbonyl, nitrosyl, ethylene, ethane 1,2-diamine. These are existing with a neutral charge. Hope you studied the charges of ligand. Now, let's go to the next topic. What are the rules? In order to name, when we discussing the IUPAC nomenclature of alkane, alkene, whatever the functional group, we need a set of rules, IUPAC nomenclature rule. Here also we need certain rules. I will discuss you one by one. Okay, the first topic and what is there, what the rule says that. But all of you listen carefully each and every rule. But finally, when we discussing the question, okay, then you can make a connection. Then it will be so easy. So very carefully, all of you listen. Order of naming ions. Order of naming ions. First of all, the cation. For example, I will give you a common salt. Which one? NaCl. Sodium chloride. Okay, sodium chloride. Sodium chloride which having sodium plus and Cl minus. This is the cation. Positively charged species is called cation. Negatively charged species is called anion. Always for an ionic compound, when you are writing the name of the ionic compound, we will write the name of the cation first. Am I right? We will write always the cation name first. Sodium is the cation, anion is the chlorine, right? We won't say chloro or sodium, something like that. Sodium chloride. Similarly, when you writing the name of a coordination compound, cationic part you write first, then go to the anionic part. You see, dear all of you, here you can see the compound is given as K4FeCN6. Dear student, what is the central metal atom in this complex? Iron. What is a ligand? Cyano. What is a counter ion? Counter ion means the square bracket, our coordination sphere, the outside species is called counter ion. Here potassium is the counter ion. Okay, dear all. So first species is called the cation. The second species, that is our sphere, that is our anion. Understood? For example, I am giving you CONH3 6 times Cl2. For example, here you can see our coordination sphere is given first. So this is our cation. This is our cation. Our counter ion is the anion. Whatever the representation, the cationic part we should write first. Then only we have to move to the anionic part. Clear all of you? So here you have to name potassium first, then name our sphere. Here you have to name the sphere first, then write the counter ion. Clear all of you? That is the first rule. What is the first rule? Cation name first, then go to anion. Next rule, naming of the coordination entity. What is coordination entity? The sphere. The sphere. The square bracket is called coordination sphere or coordination entity. In the coordination sphere, which will you write first? Dear student, what are the species you have in the coordination sphere? First of all, you have metal atom. Then you have different type of ligand. In the coordination sphere or in the coordination entity, you have initially a central metal atom, then different type of ligands. Correct? In such cases, when you naming the coordination sphere or coordination entity, write the name of the ligand first, then go to the metal. Here you know what is a ligand? Amine is there, chlorine is there. So name amine and chlorine first, ligand name first, then go to metal atom, platinum. Second rule. Let's go to the third rule, naming of ligands. We studied lot of ligands, chlorine, bromine, iodine, hydroxo, nitrito, N, nitrito, O, thiocyanato, isothiocyanato, right? En, NO, CO, NH3, aqua. So many ligands are there. How you can name these ligands? NH3 is called ammonia, but when you come to coordination compound, it's called amine. So different names are there for different ligands. When you're naming the ligand, what are the things you have to careful? Dear student, if it is a negatively charged ligand, we studied the ligands charges having three types: -1, -2 and 0 in grade 12. Okay, -1 charge, we studied now a list of -1 charged ligand, then -2 charged ligand, then neutral charged ligand. If it is a negatively charged ligand, which means the charge is either -1 or -2, their name should end with O. Their name should end with the O. If it is a negatively charged ligand, whether -1 or -1 or -2, their name should end with the O. So dear all, when chlorine comes, what we can write? Chlorido. All of you, we discussed the charges of ligands, right? So when chlorine comes, we will write chlorido. Chlorido. Previous we are using chloro. That's also ending with the O, right? But the new pattern is chlorido. Chlorido. If chlorine comes, chlorine is negatively charged ligand. It should end with the O. Chlorido. If it is bromine, bromido. Bromido. If it is fluorine, fluorido. Fluorido. If it is iodine, iodido. Iodido. If it is cyanide, it's called cyanido. Cyano or cyanido. If it is OH, OH group is called hydroxy group. It's also negative charge, right? So it should end with O. It's called hydroxo. Hydroxo. And the remaining we already mentioned. What is the name of NO2? NO2 is called nitrito N. See, it's also ending with O, right? Nitrito N. Why it's N? Because here metal atom connected to nitrogen. Same formula, here oxygen is connected. Therefore, it is called nitrito O. So, all of you, NO2 is called nitrito N. ONO is called nitrito O. Similarly, SCN, sulfur is connected. It's called thiocyanato. Whereas NCS is called isothiocyanato. Okay, so study the name, all of you, once again. Even these second set with a -2 charge, they are also negatively charged ligand. Whatever the negatively charged ligand, their name should end with O. So dear all of you, carbonate. Therefore, I told you carbonate is called carbonato. Sulfate is called sulfato. Oxalate is called oxalato. Okay, so negatively charged ligands, while you naming, careful, their name should end with O. Then, what about neutral charged ligand? For a neutral charged ligand, no special naming, no special ending. Okay, just the name of the ligand is enough. NH3 is called amine, not amino. Water is called aqua. Carbon monoxide is called carbonyl. Nitrogen monoxide is called nitrosyl. En is called ethane 1,2-diamine. En is called ethane -1,2-diamine. Okay, study their name, all of you, once again. So we were in the rule number 3. So when you're naming negatively charged ligand, their name should end with O. If you're writing a neutral ligand, no special ending. Just the name of the ligand is enough. Hope you're clear. Study, all of you. Then only you have to go to the next topic. Next one, fourth rule. What are the prefixes to indicate the number of ligand? Maybe there are a lot of ligands, right? Maybe 2 number, 3 number, 4 number, 5 number, 6 number, like that. In normal IUPAC nomenclature, when you're naming the methyl or ethyl group, if there are 2 methyl group, we will use dimethyl. If 3 methyl group, trimethyl. If 4 methyl group, tetramethyl. Same thing here. If there are 2 ligands present, we can use di, 3, tri, 4, tetra, like that. So more than 1 ligand, we can use bi, tri, tetra, penta, hexa, etc. For example, I'm giving you here, you can see this is the amine, is a ligand, Here platinum is the metal atom. It is surrounded by amine, chlorine and nitrito N. Where NH3 total 4 times are there. So what we can use? Tetraamine. Tetraamine. Right? Like that. Clear, all of you? So bi, tri, tetra, everything we can use it. One special case, let me remind you here. All of you, please be here. Let me remind you one point important. you can see that if it is a polydentate ligand, we are instead of bi or di, we are using bis. If it is 3 number, tris. If it is 4, tetrakis. If it is 5, pentakis, like that. This is commonly in grade 12 chemistry, we are using only for one type of ligand, that is our En ligand. What is the full form of En? Do you remember, dear student? En is called ethane 1,2-diamine. Ethane 1,2-diamine. This amine, this ligand, if they given in the complex, if it is suppose 2 time, okay, suppose it is 2 time, suppose they are giving you En twice. Suppose they are giving you En twice, what we need to use? Dear student, we have to use bis, then bracket. Only for En, okay, only for En, please be careful this point. If En they given twice, don't use di. We can use bis, then bracket and the name of the ligand. If it is 3 time, tris. 4 time, tetrakis. Mostly they will ask you 2 to 3. Okay, so remember bis and tris, special for En ligand. After that, order of naming. Maybe there are a lot of ligands, right? You can see there platinum is the metal atom. What is NH3 ligand? NH3 ligand is called amine ligand. What is chlorine name is called? Chlorido. What is NO2 is called? Nitrito-N. These are the name of the ligand in this given complex. You know, in a coordination sphere, metal is the ligands are there. You know, ligands we will write name first, then we will go to the metal. Yes or no? Suppose there are more than one ligand present. In this situation, you can see 3 type of ligands are there. Which one you can name first? Come to our normal IUPAC rule of hydrocarbon. In hydrocarbon nomenclature, we studied if methyl and ethyl group comes. If methyl and ethyl group comes in a compound, which will you name first? Ethyl, right? Alphabetical order we have to choose. It's the same thing here. You know, amine starting with the A, chlorido starting with the C, nitrito starting with the N. Which is alphabetical order first? Amine. So name amine first, then chlorine, C, right? C, then N. Clear all of you? That's another rule. And last one, oxidation state of central metal atom. We have to calculate the oxidation state of the metal atom, and after the metal atom, we should write the a bracket, and the oxidation state we have to write in Roman letters. Just wait, I will do the question. Through the question, I will tell you that. Last point, let me tell you, dear all. Here, what is the representation of coordination compound? Mostly for your examination, for competitive and your board examination, they will give you coordination complexes in 5 ways. 5 ways, okay. What are the types of representation of coordination compound? First of all, they can give you, this is the coordination sphere. Sometimes they will give you coordination sphere first, then there is a counter ion. For example, Cl2. One representation, okay. There will be a metal atom, there will be ligand in the sphere, and outside counter ion. So here the coordination sphere first, then counter ion. Second type, K4FeCN6. In this, what is the difference? Counter ion they given first, then your complex. Yes, right? Third one. For example, FeCN6. Just an example, okay? FeCN6. This is just a complex. There is no counter ion, right? And there is no charge also. So it's a neutral compound. Even this also neutral one. No charge is specified. Fourth representation, the same compound. For example, FeCN6. Just an example, okay? Positive. What is the speciality here? This is just a neutral compound. These all are neutral compound. No charge is specified. But here, no counter ion, but there is a charge. What's the charge? Positive. So it is a cation. It's a cation, right? It's a cationic part. Cation. And the next the other representation we can say FeCN6 minus. Here the charge is minus. This is act as a anion. Anion is a negatively charged one, right? Okay, dear all. Now, why we discussed here? Let me tell you. This is the total 5 ways they will give you coordination complexes. Okay, sometimes they will give you sphere first, then counter ion. Sometimes counter ion first, then sphere. And neutral ligand, either positive or negatively charged complexes. Now let me come back to the previous topic. Last rule, dear all. Here we are dealing with the name of the metal atom. Normally the metals we are using in coordination complexes are D block element like chromium, zinc, aluminium, iron, copper, cobalt, lead, silver, tin, gold, platinum. These are the normal metals which we are using in the coordination complexes as a metal atom. If the metal atom present in the cationic complex, what is that meaning? Here you can see the metal atom is present in the cationic part, because dear student, this is just like an ion. You know, NaCl, you can write it as Na plus and Cl minus, right? Similarly, here complex is given first, that's one ion, and counter ion second ion. So its charge is positive, chlorine charge is minus. So here your metal atom present in the cationic part, yes or no? So coordination sphere, if they are giving first, your metal atom is in the cationic part. What about here? In this question, dear student, counter ion first, so it is positive, it is negative. Here your central metal atom is in the anionic part. It is in the anionic part. Now they are saying the rule, if your central metal atom is in the cationic part, just the name of the metal is enough. If the metal atom is in the cationic part, the name of the metal is sufficient. If it is chromium, just chromium. Okay, if it is chromium, just chromium. Zinc, aluminium, iron, copper, cobalt, lead, silver, tin, gold, platinum. If your metal atom is located in the cationic part, cationic or neutral part, okay, cationic or neutral one. Here you can see that here metal atom is in the cationic part, so that just the name of metal is enough. Here your metal atom is in the anionic part, then I'll tell you what is need to use. Here it is a neutral one. Neutral one also, just the name of metal is enough. Iron. If it is iron, iron. Here also we can use iron, because you see it is in the cationic part. But in these two cases there is a difference. What is the difference in these two states? Where the metal atom present in the anionic part. In such cases, we should end the name of the metal with a ATE, 8. If your metal atom, once again I am repeating all of your final rule. Metal atom, how to name? If the metal atom present in the cationic part or neutral part, just the name of the metal is enough. If it is chromium, chromium. If it is CO group, cobalt. CO element, cobalt. Like that. But if your metal atom present in the anionic part, negatively charged part, you should end the name of the metal with the ATE, 8. For example, you can see if it is chromium, chromate. If it is zinc, zincate. If it is aluminium, aluminate. Iron, not ironate, dear all of you, iron we will call ferrate. Okay, ferrate. Copper, cuprate. Cobalt, cobaltate. Lead, plumbate. Silver, argentate. Tin, stannate. Gold, orate. And platinum, platinate. Only few of them having different name, remaining all are just the name with the 8. Okay, dear all. So only the different one is iron, ferrate, copper, cuprate, cobalt, cobaltate. Which one? Dear all of you, lead, plumbate, and silver, argentate, tin, stannate, gold, orate. That is the only one, a small difference. That's because of their name. Okay, so this is the theory. This is the rule we have to study in the IUPAC nomenclature of the complexes. Now I am directly going to the, we have to practice lot of questions, around 10 to 15 nomenclature we can discuss all of you. Then all these rule we can bring together. After doing 2, 3, 4 compound, you will get the idea and how to apply all the rules together. Listen carefully. Let's go. Question number 1. Here they are given the complex CONH3 4 times SO4 and NO3. Correct all of you? Done. Here we can say that what is the central metal atom? Here the central metal atom is cobalt. What are the ligands you have? You know, NH3 ligand is called what? Amine. SO4 ligand is called what? Sulfato. Study the name, all of you, properly. Negatively charged ligand should end with O, right? Yeah. So amine and sulfato are the ligands. Here they given the coordination sphere first and counter ion second. So this is the cationic part, this is the anionic part. Done. Clear all of you that idea? Let's go. Here we have, you know, coordination sphere. You know, if a cation and anion given, first of all we have tried the cation, right? Cation name first. Here cation is our sphere, coordination entity. In the sphere, which will you write first? Ligands we have to name first, right? Ligand is there amine and SO4. If two different type of ligand comes, alphabetical order is required. Amine starting with A, sulfate is starting with S. Amine first. How many amines are there? 4 amines are there. So what is the prefix we are using? Tetraamine. Yes. So we can use that tetraamine. Tetraamine. Okay. What is the next one? Sulfato. Only one sulfate is there. So tetraamine sulfato. What is the metal atom? Cobalt. Here we need to use cobalt or cobaltate. Here your metal atom cobalt is in the cationic part. So just cobalt is enough. So we can write cobalt. After that, please write a bracket. This is what I said. We can discuss later. After naming the ligand and the metal atom, after the metal, write a normal bracket. In that bracket, you have to write the oxidation state of the metal in the complex in Roman letters. Dear all, here how to calculate the oxidation state of cobalt? You don't know directly what is the oxidation state of cobalt, right? Let me take it X. Please take the sum of each and every ligands and counter ion. Amine, dear student, I told you what is the charges of each and every ligand. Amine is a neutral ligand, charge is 0. Take the sum, okay. Sulfate, what is the charge of SO4? 2 minus. So minus 2. Plus, even counter ion if it is there, that also we have to consider, okay. What is the counter ion? This is not NO2, okay. We studied now NO2 and ONO. NO2, what is called? Nitrito-N. What is ONO is called? Nitrito-O. That is nitrite, okay. This is nitrate. This is NO3. NO3 charge is also minus 1. Nitrate, okay, nitrate. So its charge is also minus 1. Dear student, overall the complex is neutral. How we can understand overall it's neutral? Can you see any charges specified on the complex? No, right? It's overall neutral complex. So if it is a neutral compound, all sum of the species is equal to 0. So we are actually calculating the oxidation state of the metal. Okay, how to calculate? Whatever the metal ligands and counter ion given, take the sum of each of their charges. And what you can write on the RHS? If it is a neutral compound, the RHS is 0. If it is a charged compound, the charge should be right on the right side. I'll tell you, we can discuss a lot of questions. So what is X value here? X is equal to, I think you will get it as plus 3. You know, oxidation state of a metal always either positive, in few cases 0. So here 3 is the oxidation state that we need to write in the bracket as Roman digit, okay. So 3. Don't write normal letter 3. In Roman letters we have to write. So 3 is the one. Okay, so that's over. And your counter ion is left, dear student. What is your counter ion? Nitrate. Counter ion, just the name is enough. Okay, counter ion, there is no special ending. Whatever the counter ion, just the name of that counter ion is enough. Even their number also, no need to specify. If there are 2 NO3 group, you no need to say dinitrate. Okay, just the name of the counter ion is enough. What is NO3 is called? Nitrate. So all of you, what is the meaning of tetraamine? 4NH3. What is sulfato? 1SO4. What is cobalt? That is our metal atom. What is this 3 represent? That is the oxidation state of the metal. What is nitrate represent? The counter ion. Let's go to question number 2. In question number 2, okay, in each question, let me calculate the oxidation state first of all. Then that duty over. So here metal atom is cobalt. Let us calculate, dear all of you. If you want to know the metal oxidation state, we should know the charges of each and every ligand. So study the charge of each ligand, come to this point. Okay. Cobalt oxidation state directly we don't know. Let us take it as X. Take the sum of each species. NH3 amine is a neutral ligand, charge is 0. H2O is a neutral ligand, charge is 0. Bromine, you know, one bromine, halogen charge is -1. One bromine charge is -1 plus. NO3, nitrate charge is -1. There are two nitrate group, therefore -2. Overall, it's a neutral compound because no charge given. So overall is equal to 0. So what is the value of X, dear all of you? You will get it as +3. That duty over. Now let's go for the name. Here all of you, here also the coordination sphere is given first, right? Coordination sphere given first. So that is the cationic part. This is our anionic part. So cation name first. Here what are the ligands you have? NH3, you know, it's called what? Amine. H2O is called what? Aqua. Bromine is called what? Bromido. Bromine is called bromido. If different ligands comes, we have to follow the alphabetical order. Amine starting with the A and aqua also starting with the A. Oh, confusion. Which one can be right? Amine or aqua? Both are starting with the A, right? In such cases, look into the next letter. Here, amine starting with M and aqua starting with the Q. Which is alphabetical order first, M or Q? M, right? So amine and aqua when comes, amine first. How many amines are there? 4 amine. So I can say tetraamine, then aqua, only one bromine, right? So bromido, no spaces, okay? Directly we can write. Tetraamine, aqua, bromido, ligands over, come to metal, cobalt. Here why cobalt? Why we are not writing cobaltate? Because here cobalt is in the cationic part, just cobalt is enough. So cobalt, after the metal atom, put the bracket. We already calculated the oxidation state, that is 3. What is your counter ion? Nitrate. I told you, dear all, counter ion, there is no special ending. Even their number also no need to specify. There are 2 nitro group. Don't want dinitro. Just the name of the ligand is enough. Sorry, the counter ion is enough. Nitrate. What is that? NO3 is called nitrate. Go to question number 3. Here there is a difference, all of you. What you observe? What is the difference? What is the difference in the third question? Here, potassium, counter ion given first and your complex given second. Correct or not? So this is our cationic part. Your complex sphere is the anionic part. You know, whatever the cation or anion, cation we should name first. Which is your cation? Potassium. There are 3 potassium, right? I told you counter ion number, no need to specify. There are 3 potassium, just we need potassium. Counter ion number, please don't specify. Potassium. So starting with the potassium, then potassium, okay. Then enter into your complex. In your complex, ligand first of all. Total 6 cyanide is there. Cyanide, if it comes, it's called cyanido. 6 cyanides are there, therefore it is called hexacyanido. All of you, potassium, hexacyanido. What is your metal atom? Iron. But are you going to write iron directly? Please don't write. Because here your metal atom is in the anionic part. If the metal atom in the anionic part, we should end the name of the metal with 8. If iron comes, what we use? Ferrate. Right? We can use ferrate. After the metal atom, we need a bracket and the oxidation state. I think we didn't calculate the oxidation state, right? Okay, let's calculate. How many potassium outside? 3 potassium. You know, potassium is a first group element, charge is +1. 1 potassium charge is +1, so there are 3 potassium, so charge is +3. Plus. Iron oxidation state supposed to calculate, take it as X. You know what is the charge of cyanide? 1 cyanide, Cn -1. So 6 cyanide charge is -6. Overall, it's a neutral compound, 0. So X is equal to +3. That 3 you can write in Roman letters. All of you clear? Very simple. Let's do some more question we can make in this video. After this video, you should be able to answer most of the questions. Okay, let's go to the question number 4. Here we have the question K3FeC2O43. It's a neutral compound, no charge given, right? Here all are neutral compound. How we can say it's a directly neutral compound? Because there is no charge mentioned. Okay. Here, potassium is given first, so that is our cationic part. Our complex sphere is our anionic part. Anyway, cation we can name first. What is your cation? Potassium. Let's go dear all. Potassium. Potassium. Get into the sphere. In the sphere, ligand. Can you able to understand what is the name of the ligand? C2O4. C2O4 2 minus, that is called oxalato. Sometimes they will represent OX. C2O4 is called oxalato. Okay, potassium, how many oxalato? 3 oxalato is there. Therefore, trioxalato. Your metal atom is iron, but it is in the anionic part, so it should end with the ferrite, right? So we can use ferrite. After that, the bracket and the oxidation state. Yes, student, 3 potassium outside. 3 potassium charge is 3 because 1 potassium plus 1 charge, 3 potassium plus 3. Ion oxidation state we don't know, X. What is the charge of 1 oxalate ion? C2O4 2 minus. 2 minus charged species, 2 minus 2 charged ligands we studied only 3. What are they? Carbonate, CO3 2 minus. Sulfate, SO4 2 minus. And oxalate, C2O4 2 minus. So 1 oxalate charge is minus 2. There are 3 oxalate, so minus 6. Overall, it is a neutral compound. So charge is 0. So X is equal to plus 3. So we can write in Roman letters. Clear now? Potassium trioxalato ferrite 3. Question number 5. Let us first finish I think better to finish the oxidation number, right? Okay. Nickel, here the complex is just neutral. Only its coordination sphere is given, no counter ion. Okay. Here metal atom is nickel. What is CO ligand is called? Carbonyl. Carbonyl. It's a neutral ligand, right? Carbonyl. Then, let us calculate the nickel oxidation state. We don't know directly now, right? X. What is the charge of CO ligand? CO is a neutral ligand. What are the neutral ligand we studied in this chapter? Amine, aqua, carbonyl, nitrosyl, En. These are neutral charge ligand. No contribution for this one. And overall charge is 0. So X is equal to 0. As I told you, some of the compound, most of the complexes, coordination, the metal atom is in positive oxidation state, plus 3, plus 2, plus 4 like that. But in some cases, it is 0. But of course, we can say it should not be negative, okay? Because it's a metal, right? Okay, right. Then we can go for the name. Total tetra. 4 carbonyl ligands are there. It's called tetracarbonyl. Tetracarbonyl. Nickel or nickelate. Dear student, if the metal atom present in the cationic part or neutral part, no need of special ending. Okay, nickel. That's enough. Tetracarbonyl, nickel. The oxidation state is 0. Tetracarbonyl, nickel, oxidation state is 0. Next one, dear all of you, careful this question. This is important. First of all, let me calculate the oxidation state of this cobalt here. Cobalt oxidation state, I don't know directly. Let me take it as X. 1 chlorine charge is minus 1. So 2 chlorine charge is minus 2. Okay, done. En, ethane 1,2-diamine, its charge is 0. It's a neutral ligand. SO4 is the counter ion. Counter ion, the value also we have to add it. Okay, sulfate. What is the charge of sulfate? SO4 2 minus. Okay, minus 2. Overall, it's a neutral compound, so 0. So X is equal to plus 4. Okay, oxidation state we are getting as plus 4. Done. Now we can go for the name. Okay, here the metal atom is cobalt. What are the ligands here? Cl2. What is Cl2 is called? Chlorido. What is the name of En? En is called ethane 1,2-diamine. Ethane 1,2-diamine. If 2 different ligand comes, we have to follow alphabetical order, correct? So chlorine first. It's starting with a C, A, B, C, D, E, right? C first. How many chlorines are there? 2 chlorine. So we can say dichlorido. Dichlorido. En, we studied a special naming system. Do you remember? En is called ethane 1,2-diamine. If it is 2 times, we are not using di. What we are using? Bis. If it is 3 times, tris. Okay, only for En we are using that special for a bidentate ligand. So we are using 2 times are there, therefore bis. After that, write the bracket and write the name of the ligand. Bis, ethane, 1,2-diamine. And what ligands? Everything is over. What is your metal atom? Cobalt. We can use cobalt only, no? Because it is in the cationic part. Cobalt. After cobalt, what is the oxidation state we calculated? 4. We should write in Roman letters, okay? 4. And what is our counter ion? Sulfate. Sulfate. Don't write sulfate or sulfato. If sulfate coming as a ligand, if it is present inner side of this which one coordination sphere, we will end with the O, sulfato. But now it is a counter ion, so just sulfate is enough. Clear all of you? Next one. Here the coordinations complex. Here in all these 7th, 8th and 9th example, the coordination sphere is given first. So that is in the cationic part. Counter ion is there. Okay, then let's go dear all. Let me calculate the oxidation state immediately. I will give you a short trick method, not an idea. If you know the charges of each and every ligand, you can, by looking the compound itself, you can able to understand what is oxidation state. Let me tell you one of the example. Cobalt oxidation state we don't know, right? Okay, just keep it there. Amine is a neutral ligand. You know, neutral ligand charge is 0. It's not giving any contribution for calculating the oxidation state. Then remaining 1 chlorine. You know, 1 chlorine charge is -1. Outside also 2 chlorine. So 2 chlorine charge is -2. So -1 and -2. Total -3, right? Anyway, it will come to the right side. It become +3. Oxidation state of metal is positive, right? So +3. So you just analyze the charges of the each ligand, you add it. Here 3 chlorines are there. 3 chlorine charge is -3. It will come to the right side, +3. So here oxidation state is what? +3. For the metal atom cobalt, +3. So let's go for the name, dear student. This is amine, this is chlorido, amine first. Total 5 amines are there. So we can say pentaamine, and chlorine. Therefore we can call chlorido. And the metal atom is what? Cobalt. After that bracket, and the oxidation state is 3. And outside what you have? Chloride. If chlorine coming as a ligand, we should end with the chlorido. O. If it is act as a counter ion, just the name chloride. What about 8th question? So 8th question, can you able to calculate what is the oxidation state of chromium in this question? Can you able to answer directly, dear all? Dear all, aqua is a neutral ligand, 0. It's not giving any charges. There are 2 chlorine charge is -2. We will add this chlorine also. So plus -1, -3. Total 3 chlorines are there. 3 chlorine charge is -3. Anyway, it will come to the right side, right? It become +3. So +3 is the oxidation state. So oxidation state is equal to +3. Let's go for the name. Total aqua and chlorido. Alphabetical order, aqua first, right? So tetra aqua, 2 chlorine. Therefore, dichlorido. Your metal atom is chromium. Very careful, okay? Chromium. What is the oxidation state? 3. And outside what you have? Chloride. Practice everyone. Practice. Question number 9. Can you tell me what is the oxidation state of chromium in this case? Very good, dear student. I hope you get it as again +3. Correct? Because aqua is a neutral ligand, no charge. 3 chlorine total, 1 chlorine Cl -1. So 3 chlorine -3. When it come to the right side, +3. Okay, so here also oxidation state is +3. Aqua only there. So total 6 aqua is there. Therefore, hexa, aqua, chromium. Oxidation state is 3. Outside you have chloride. Clear all of you? Hexa, aqua, 6 water, chromium and 3 chloride. Next one, dear all. Question number 10. All of you listen. Here also in all these cases we can see coordination sphere is given first. So that is a cationic part. I think this is a neutral complex. There is no counter ion. Fine. Let's go, dear all. Can you able to answer directly? Just try. Okay, just pause the video. You just write your name, your own name. Okay, you give a IUPAC name for this compound. Then continue the video. Check it correct or no. Total 6 amines are there. Let us calculate the oxidation state first of all. Can you tell me what is the oxidation state of the platinum metal in this complex? You know, amine is a neutral ligand. I hope you get it as +4. Yes? Because amine is a neutral ligand. The total 4 chlorines are there. 4 chlorine will give you -4. It will come to the right side +4. So X is equal to +4. Here total 6 amines are there. Therefore the name is called hexaamine. 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 And the metal atom is called what? Platinum. Platinum. Oxidation state we already calculated as 4, Roman letters, okay, 4, and outside what you have? Chloride. Chloride. Question number 11. What is the oxidation state of cobalt in this question? Dear student, amine is a neutral ligand, no charge. NO2, what is NO2 name is called? Nitrito-N. NO2 is called nitrito-N, ONO is called nitrito-O. So when NO2 charge is NO2 or ONO, their charge is -1. So total 1 NO2 charge is -1. There are 3 NO2, therefore -3. Correct or not? -3. So -3 when come to the right side, it becomes +3. For understanding, cobalt oxidation state X we don't know. Amine is a neutral ligand, so 0. 1 NO2 charge is -1, so 3 NO2 charge is -3. Overall, it's a neutral compound, 0. So X is equal to +3. Here amine is there, nitrito is there. Amine starting with the A, nitrito starting with the N. A first, right? So there are 3 amine, therefore triamine. Triamine. There are 3 nitrito-N group. Therefore, trinitrito-N. Why it is called nitrito-N, dear all? Because it's starting with the N, right? Now, NO2 is called nitrito-N. ONO is called nitrito-O. So, nitrito after that hyphen N. Again one more hyphen. Okay, very careful. Nitrito hyphen N and again hyphen. Then the name of the metal. Metal is cobalt. What is oxidation state of cobalt? We calculated 3. So all of you, triamine, trinitrito-N, cobalt, its oxidation state we calculated as 3. Next one. Here silver is the metal atom. We don't know the oxidation state X. Amine charge is neutral. Only 1 chlorine charge is -1. Overall it's a neutral compound. So X is equal to +1. Right? +1. So dear all, 2 amines are there. Therefore, diamine, silver. Silver, okay, because it is in the cationic part. Silver, just the name of the metal. Silver, what is oxidation state? 1. And outside what you have? Chloride. Check it once again. Diamine, silver, 1 chloride. Next one, dear all. Careful, these are very important one. Here also coordination sphere given first, then counter ion second. Chromium is the metal atom, so X. Amine is neutral, so 0. 3 chlorine charge is -3. En is also neutral. Chlorine charge is -1. Overall, it's a neutral compound, no charge given, so 0. So X is equal to +4, right? -3 plus -1 -4, come to the right side, +4. Dear all of you, there are 3 ligands given in the question. What are the 3 ligands? You have, what is NH3 is called? Amine. What is Cl is called? Chlorido. What is En is called? Ethane. Ethane 1,2-diamine. Which is alphabetical order first, starting with the A, starting with the C, starting with the E. Of course, amine, right? How many amines are there? 2 amine. Therefore, diamine. After A, C is right, A, B, C, D, E, C. Total 3 chlorines are there. Therefore, trichlorido, then En. Only 1 En is there. If there are 2 En, we will write bis ethane 1,2-diamine. If it is 3, tris, like that. Here only 1 En. So what we can say? Ethane 1,2-diamine. ethane 1,2-diamine. Okay, ethane 1,2-diamine. And what is your metal atom? Chromium. You should write straight, okay? There is no space, so I'm writing below. What is the metal atom? Chromium. Chromium. What is the oxidation state? 4. And outside what you have? Chloride. All of you, once again. Diamine, trichlorido, ethane 1,2-diamine, chromium, oxidation state is 4, and outside what we have? Chloride. Question number 14, all of you please observe carefully, very important. What is this NH3 ligand is called? Again, you know, amine. What is Cl is called? Chlorido. What is ONO is called? You know, NO2 is called nitrito N. ONO is called nitrito O because the bond is with oxygen, right? It's called what? Nitrito O. Which is alphabetical order first? A first, then C, then N. Okay, let's go. Total 4 amines are there. Therefore, tetraamine, then chlorine. Only one chlorine, therefore chlorido. And then ONO. What is ONO is called? Nitrito O. After that, one more hyphen, okay? When you're writing metal atom, one more hyphen. What is the metal? Cobalt. Cobalt. What is oxidation state? We didn't calculate it, right? Okay, let's calculate. Cobalt oxidation state, we don't know. X. NH3 is a neutral ligand, 0. One chlorine charge is -1. ONO charge is what? -1. All of you, this is a positively charged complex. It's not neutral, right? Can you see there is a overall positive charge on the complex? Now almost all the complexes, we took the sum is equal to 0. But here you cannot write like that. If it is a neutral complex, you can write 0. But this is a charged complex. If it is a charged complex, the charge you should write on the right side. What is the charge given? +1. So here we can write +1. Whatever the charge, you have to write that. Okay. So x is equal to -2 plus 1 is equal to +3. So what is oxidation state? +3. Check it all of you once again. Tetraamine. Total 4 amines are there. Chlorido, 1 chlorine. Then nitrito O. Cobalt. Okay, cobalt. All of you, one more thing. Suppose the charge I am giving as negative. Instead of this positive, suppose I am giving negative. So here your metal atom in a anionic part. Then not writing cobalt, we have to write cobaltate. Okay, if the metal atom is in the anionic part, we should end with the H. Here it is a positive part, therefore just a cobalt I used. Last question, all of you. What is Cl is called? Chlorido. What is En is called? Ethane 1,2-diamine. Again, which is writing means to get that concept, okay? Total, which is alphabetical order first? C first, then E. Total 2 chlorines are there, therefore dichlorido. Total 2 En group is there, dear student. En group, if it comes, we are using bis and tris, like 2 bis. So bis bracket ethane 1,2-diamine. After that, what is the metal atom? Chromium. What is the oxidation state? Chromium oxidation state X. 2 chlorine charge is -2. En is a neutral ligand. One more chlorine -1. Overall 0. X is equal to +3. 3, and what do you have outside? Chloride. Check it all of you once again. Correct or not? Dichlorido. Ethane, 2 En are there, therefore bis ethane 1,2-diamine. Chromium oxidation state we are getting as +3, and outside you have chloride. So this is the nomenclature of IUPAC nomenclature of which one? Coordination compounds for your grade 12. If you know the nomenclature of coordination compound, then only you can able to answer most of the other concepts. As example, VB theory, crystal field theory, Werner's theory, their oxidation state calculation, everything. So dear all, hope you get the concept how to name the coordination complexes, their IUPAC name. Okay, IUPAC name. So in order to answer the IUPAC name of the coordination complexes, we have to know, first of all, what is the charges of ligand. Okay, study overall the charges of ligand. I told you -1 charge ligand one set, -2 charge ligand and neutral charge. Study the ligand charges first. Second, the rules. If a cation and anion part is given, always write the cation first, then go to the anion. Correct? And after, when you naming a coordination sphere, in a coordination sphere, you have a metal atom with a ligand. Ligand name first, then go to metal. If there are different type of ligand as per the alphabetical order, write it. If there are many number of ligand, if it is 2 comes di, 3, tri, 4 tetra, we can use it, except En. For En ligand, we are using bis, tris, like that, right? After naming the ligand, go to the metal. After writing the metal, write a bracket, and in the bracket, you just write the oxidation state in Roman letters. Counter ion, if it is there, write it. Now, one last point. If the metal atom, how to name metal? If the metal atom present in the cationic part or in the neutral species, neutral part, just the name of the metal is enough. If the metal atom present in the anionic part, negative part, or anionic part or with a negative charge, they have to end with 8. Cobalt means cobaltate. Iron means ferrate. Gold, orate. Silver, argentate. And copper, cuprate. Nickel, nickelate. Like that. So study all the theory and keep practicing the questions once again. Hope you clear the concept how to name the IUPAC nomenclature of coordination compound. So dear all, thank you all. See you again.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.